was Connolly, and this was Gitzo. Now, what we observed in the Arizona schools, by the way, please, if you want to comment, if you want to question, if you want to object to anything, speak up so we can get a dialogue going in this part. Basic thing is the state education standards are abysmal. Okay? They're so atrocious it defies description. Because the middle school does no quantitative physics until the 8th grade when they do Newton's laws. Before that, all studies are qualitative with no basic principles defined. We've also found that math knowledge and ability is inadequate. I mean, we're finding 6th and 7th graders who can't multiply and divide fractions. And the class, what I experienced, had a class of 27 kids, one student, a girl, could divide 2 by 9. And 6th, 7th, and 8th graders can't do basic algebra. Newton's law, second law, F equals MA. We asked, okay, how do we solve this fray? Silence. So then we try stepping them through. It becomes clear they have no idea what we're talking about. Then the standards severely limit what is being taught. The focus at 6th and 8th is on inquiry and scientific methods. And it's at the expense of principles, laws, and analysis. And many districts have curriculum maps that tell teachers what to teach and when. I mean, I'm in Tempe. We do Tempe schools. I've actually met with the Tempe district, with the coordinating of math and science at the district level on this. And I've experienced teachers, I'll say, being frightened to bring us in because of the curriculum, what it says they can do, and what they can do. We don't say, how about we do this lesson? No, we can't do that. It's not in the curriculum. You know, we do that in this month. This is ridiculous. The other thing is that many or most schools have no or inadequate lab facilities, can't have offer students lab experience. All the schools we're going to now around Phoenix, there's one, Orangewood, that has a lab. The rest is just a room and maybe a synthetic stone surface counted on the side. There may be one sink, but that's it. It's not a lab. And the kids are not doing lab sessions. And one teacher I was talking to, we were setting up a lesson, he said his kids asked him, can we do some labs? He said, well, I'd like to, but I can't. We don't have the equipment, we don't have the facilities. But the major emphasis of the standards is on inquiry and scientific method. You can't do that without doing lab sessions. This is out of those standards, just, you're familiar, so no. The emphasis, 6th, 7th, and 8th, which is where we work, is on these things, which is all the fluff as far as we're concerned. The science down here is very light. And when we go over looking at physical science, physics, I mean, look at all those white areas, Earth and space science. You can't do Earth and space science without understanding physics, sorry. Well, physics laws are fundamental to how Earth and space science is operating. So this is a major problem. So when we started this whole program, we weren't aware of this. We go in all naive, gung-ho, enthusiastic. And we started banging into this with the teachers. And so we started doing more research. So the question then we had in our minds is there some way we could get around this? Just a final comment. This is from Bill Schmidt, who's Director of Institute of Research. He makes the complaint that here in the US, our kids are still studying basic arithmetic and they're doing very elementary descriptive science. I call it rocks and body parts, which is what we've just been saying. So, what we thought is, okay, let's use this emphasis on inquiry and scientific method to add in all the stuff that's missing, but do it in the lab setting. So that's why our whole emphasis in our lessons is now shifted to being not, as it were, we're teaching and then reinforcing with a lab session. We're doing a lab session, period, with teaching integrated in there. So what we do is we use the first day for a lecture on the principles with lots and lots of demos. These are demos we'll be using tomorrow in the obstacle bridges when we talk about structures. And we cover physics topics which are not in the standard, but which all those kids need to know at that age, and they're ready to learn. And we're finding when we teach the kids that, they respond very positively. They're thrilled to be learning this stuff. These are the things we're covering right now in our lessons. There's a mechanical advantage, simple machines, work, potential kinetic energy, conservation of energy, the nature of electricity. What is electricity? We talk about the electrons moving around and why. Electrical circuits, serial and parallel circuits, Ohm's law, Archimedes principle, but I do this principle. How does an airplane fly? To explain that, I put the standard. Structures under compression and compression and tension. Electromagnetism. We have one that's called all about electric motors. We cover magnetism, electromagnetism, and the kids build an electric motor that works. And it's not one of these party trick motors, it's a real electric motor, and you'll see later on. And extensive lab experience. We have them doing stuff, and we've introduced a lot of what I call it measurement, and testing and timing, etc., to see how well they're the things they build operate. So we're doing, we use all that simple hands-on demos. Talk will be doing this one tomorrow. The current carrying wires, etc. We use real examples of everyday objects, motor suspension bridges. I was amazed how many 6th, 7th, and 8th graders were very familiar with the recoil of a gun. This is one of our demos. I mean, they're simple. Mapping the field of a magnet using compass. I mean, you see it in the books, diagrams showing how Faraday mapped the field using compasses. We put a bar magnet down, give them a set of compasses and say, so here's how you do it. And they move them around, and you see how the compass needle moves and swings around as they move it around. Sheet of card, sprinkle light, filings on, magnet underneath. They're doing it, they're moving the magnet, put it on there. They're seeing how the apparent field lines. And the thing we emphasize is we talk about the magnetic field lines, but it's not actually lines. We use that term simply because that's what it looks like. That it's actually a diffuse field. You just like the light in here. It's diffuse, it's not lines. Magnetic field due to current flow. You get the kid holding it. Just a wire, we connect the battery across, and they see the compass needle kit. Similar thing. We show how you run current through two wires, or in this case two aluminum foils. If the current's in the same direction, the foils move together. The currents are in opposite direction, they move apart. mean, this was a discovery back at the beginning of the discovery of electricity. It's in the textbooks. We've got it set up, they can see it, they can do it. And that's a cheap one to set up, it's just easy. Piping to make the frame, then aluminum foil, and a battery we can get you across. How an iron core increases the field strength of a coil. We've got a coil of wire, this is actually coil of wire like you buy in the Home Depot, to buy additional wire, that's what that is. And we have some compasses over here. We connect the battery, we have the compasses set, so that when you connect the battery they only twitch slightly. Then we just put this steel bolt in the middle, connect the battery again, now the compasses really move, because you've concentrated the field. You know, it's graphic. Traction, repulsion, two current carrying coils, we actually have two coils suspended. Connect batteries to them, you see coils move apart and one. In fact, we made one rotate. This was the early days when we started. We were suspending coils. Now, we've actually built an open frame electric motor. Again, these are spools of wire. When you buy wire, that's all we've used. And we're using two little bolts in the middle, like these stator, and then we have, this is a Lazy Susan. And the armature coils just sat on the turntable. Around the edge of the turntable we have two copper strips. And then pressing against that, there's the tension rollers from screen door. That makes our brushes. So now we have an open electric motor and we're able to show how the motor works. The other thing we do when they build their motors is we measure the motor speed. We use an oscilloscope, data oscilloscope actually. We're looking at the current loss that's taken by the armature. And from that we can calculate the revs per minute the motor's doing. And we tabulate them on the board. And for each kid's motor, so it becomes a competition. Who's got the best motor, who's done the best construction job. And you know, we're getting speeds here like 5,200 RPM from this little motor, which the kids put together. You know, that surprised us. Was that a record, Dave?
The record's actually 7,200,
yeah.
And some of them literally smoked.
Yeah.
But one of the things we found was the kids love to compete. They just love to compete with each other, so we encourage them.
Yeah. So they'll ask for extra batteries so they've got more in series, get more voltage.
Not supposed to do that, but that's, those are the ones that smoked.
We use a lot of construction projects to reinforce this build a cell work for Archimedes, Newton's laws, a water mill, the levers and mechanical advantage. And there, the competition is to lift a weight of steel washers. Okay? And those water, when you saw it in the video, again, we were amazed. The record on that is 4.2 kilograms of steel washer being lifted by one of these wheels they built, just a jet of water from a fountain top falling into the bucket. Solar-powered cars for electrical circuits and solar cells. That's one of the most popular ones. They race the cars. Best course for that is a basketball court. There's lots of room. And to my amazement, to this day, no one has yet stepped on one of these cars. There's cars and kids go in all directions. Build a little bridge for those carrying structures. You're going to be doing that. And there the record is 75 pounds, 75 pounds. Load carried on the bridge. 24-inch span of the bridge. So build the electric motor, electromagnetism, build a bottle rocket for Newton's laws. Now you're going to be doing a lot of rockets, I'll just mention something